Okay guys, since it's our first online lesson, we're gonna only do about half of 7.4. So find 7.4 in your packets. We're only gonna be doing half of the objective, so we're gonna use sum and difference formulas to evaluate trigonometric functions and verify identities. We're gonna solve trigonometric equations for tomorrow or the next day. So these right here, sum and difference identities right here, those are either going to be what I've been calling your note card stuff or your things to memorize if we ever, take a test again. That's going to be stuff that you're going to want to put on your note card. But before we get started, I want to back out and go to our unit circle here. And just direct your attention here to the first quadrant. I want you to think about these numbers here in the first quadrant. I'm so sorry, guys. I keep flipping. Here we go. These numbers in the first quadrant that we have exact values for. Because what we're going to be doing is rewriting other numbers, whether they be radians or degrees, with these that we actually know exact trig values for. So I know that doesn't make much sense right now, but in a second it will. Just like I always say, I know it doesn't make a lot of sense until we actually start doing the notes. So let me go down here to where we were at in our notes. Okay, so you're going to want to keep these sum and difference identities handy. And what I did in my own paper copy of the notes is I actually numbered them. So I numbered this one, number 1, number 2, number 3, number 4. And then number 5 and 6 we actually won't get to today, but still just number them just for funsies right now. So rewrite, here's your steps. Rewrite angle as the sum or difference of two angles whose exact values are known. So those exact values, you want to get those exact values from the unit circle. I also apologize for my awful handwriting. My stylus is not very good. Second step, you're going to want to choose the correct identity. So just choose the correct one of these up here. Plug in and simplify. So simplify meaning go to your unit circle, or if those of you who are good students and have it memorized, just pull up those from memory or pull it out and pull it out of your brain. So let's just jump right in and do an example. I'm so sorry this is rough, guys. This is my first online lesson. So find the exact value of sine pi over 12. Okay, sine pi over 12. That's not a value on our unit circle that we have like a square root of 3 over 2 or root 2 over 2 or 1/2 4. If we would enter it onto our calculator, it would give us a nasty decimal. We can't use a calculator because it's asking for an exact value. However, when you are done, I'm going to encourage you to check on your calculator. So it's a good thing to have your calculators out checking at the end. So that might be a good thing to do. So what we want to do is think, how can we rewrite just pi over 12? Forget about the sign for right now. How can we rewrite pi over 12 in terms of, now this is in radians, so obviously we only want to think about pi over 6, pi over 4, and pi over 3, pi over 2, pi, all of those radian degree, or radian, not degrees, those radian measures. Usually we jump to pi over 3, pi over 4, and pi over 6. Pi over 12 is a pretty common one, and it is pi over 3 minus pi over 4. And here's how it works. Because if I would get a common denominator here, and the common denominator is pi over 12, I would multiply and get a common denominator. This would be 4 pi over 12 minus 3 pi over 12. Oh, shoot. What did I do? Uh-oh. Sorry about that. Here, Here we are. 4 pi over 12 minus 3 pi over 12, which would give me 1 pi over 12. So that shows you that sine of pi over 12 can be rewritten like the sine of pi over 3 minus pi over 4. Okay. Well, if we go back up to our identities over here, that's this green one that I just underlined, number 2, sine A minus B. Our A would be pi over 3. Our B would be pi over 4. So we would have sine pi over 3 cosine pi over 4 minus, this is a bad minus, cosine pi over 3 sine pi over 4. Well, the sine of pi over 3 we know from the unit circle is root 3 over 2. Oh my goodness. And cosine of pi over 4 is root 2 over 2. Minus cosine of pi over 3 is a half. Sine pi over 4 is root 2 over 2. Multiply this out. Remember, inside times inside, so we can take root 3 times root 2, which is root 6 over 4, minus root 2 over 4, which is root 6 minus root 2 over 4. And we cannot simplify those square roots at all. There are no perfect squares in square root of 6 or square root of 2. We cannot simplify at all. So that would be our exact value. Now, if you did check that on your calculator, you would get something around 0.259. Make sure your calculator is in radian mode. So that would be a good way to check your work. Okay, now would have been a good opportunity for you to try the try while I've been just sitting here in awkward silence because, I'm not used to doing this. And this kind of sucks a lot, doesn't it? So, we already did pi over 12, so we know that it is pi over 3 minus pi over 4, but this time it's cosine. So this time, instead of using number 2, we're going to be using number, number 4. So cosine A, cosine B plus sine A, sine B. So cosine pi over 3, cosine pi over 4, plus sine pi over 3 sine pi over 4. So, what do you notice about this, guys? As if you'll answer me, right? When we had a difference formula, look, it was cosine A minus B, but we used a plus. In the last one, we had sine A minus B, but we still used a minus. So with cosines, it's like the opposite. Doesn't make much sense, does it? Like, what the heck, cosines? What are you doing with your life? We don't really know. But we're just going to go with it, right? We got to. All right, so cosine pi over 3 is... What is cosine pi over 3? Cosine pi over 3 is a half. So we have a half times root 2 over 2. And then we have sine pi over 3, which is root 3 over 2 times root 2 over 2. And guys, remember throughout this whole thing, if I'm going too fast for you, this isn't like in class where you have to raise your hand and tell me to slow down. You're doing this on your own time, so you can just pause me. Remember, do this on your own time. If I'm going too fast, just pause me, rewind me, mute me, do whatever. So this would be root 2 over 4 plus root 6 over 4. Make sure you check that on your calculator. All right, now we're going to try it with degrees. Oh, no. Okay. This is hard. And I'm moving right along because you guys can pause me if you need to. All right, I feel like degrees is easier for you guys. 75 degrees. What adds up to 75 degrees? Well, 45 and 30 degrees, of course. So let's go back up to our identities here. Which one are we going to use? We're going to use number 3, right? So we're going to use cosine A cosine A times cosine B minus sine A sine B. Remember the commutative property of multiplication? So even if I were to switch 30 and 45 degrees with the addition sign, it wouldn't matter because I have cosine 45 degrees, cosine 30 degrees, minus sine 45 degrees, sine 30 degrees. So cosine 45 degrees is root 2 over 2. Cosine 30 degrees is root 3 over 2. Sine 45 degrees is root 2 over 2. Sine 30 degrees is a half. So this would give me root 6 over 4. Uh-oh, it's not letting me write. Sorry, guys. Minus root 2 over 4, which would give me root 6 minus root 2 over 4. Remember, if you're checking this one on your calculator, please switch to degree mode. And if you want to try without me, go ahead and do it now before I jump right in. I'm going to switch the color. So we already know 30 degrees plus 45 degrees. So this one's sine, so we're going to be using number 1 here. So sine A cosine A, cosine A sine B, sine A cosine B, cosine A sine B. So let's just say A is 45. Oops. And B is 30. So we've got sine 45 cosine 30 plus cosine 45 sine 30. Okay, if we're going to be doing this, I need a better stylus. So sine 45 is root 2 over 2. Cosine 30 is root 3 over 2. Cosine 45 is root 2 over 2. And sine 30 is a half. So I know these first, how many have we even done? Oh my goodness. Oh my goodness, guys. I'm struggling. We've only done 4 examples. These first have been really, really similar, and we've already spent 20 minutes on this video. But, anyway, that's about it so far. So this again is root 6 over 4 plus root 2 over 4. So root 6 plus root 2 over 4. And I think I'm going to stop here for tonight since this is the first one and I don't want to overwhelm anyone. And just to make sure this video, actually turns out okay. And because, this probably sucks a lot because it's my first video. And I'm sorry if anyone's ears are bleeding because of this. And I'm sorry for my messy work. So please feel free to comment on the post with any questions, email me with any questions, text me with any questions. Just contact me with any questions, guys. I'm so sorry about this. So I'll see you next time, I guess.